This is going to be the second setup on this part for the 4th axis base update, and we're going to try it and see how it runs here. I went through my tool table and checked everything out. I always try to do that. It's just a habit, and I did find that this particular tool was off some, so I'm glad I go through and do that every time. I don't exactly know. It always seems to be a drill bit that seems to be off some for some reason, and I don't know why, but it may be me just making a mistake in my tool table. But I always go through and check it beforehand and make sure everything's okay. I'm gonna switch over to I guess it would be called a different screen set for Mach 3. It's called Mach Standard Mill, and I plan on doing that this weekend sometime, and I thought I would try to knock this part out before I did that. I'm hoping that the new screen set, or the new software anyways, it's Mach 3. It's just, I think it's a different screen set for it, so I'm hoping that it will help improve like the use of the tool table. And I believe it has a feature where it will not recognize the tool, and what it'll do is it will go and probe the tool height before it machines. I haven't learned all there is about it yet, but I believe it will go and acquire the tool height. So if that be the case, then I won't have to worry about drill bits. I just have an open chuck, load it in the machine, put my drill in, and then go probe the tool height for that particular drill bit in that process. So that will be nice. It will be kind of like setting the tool height on the fly, I guess. So that'll be very flexible, and it's going to be a big learning curve, and that's one reason why I wanted to try to wait until after I had got this part done and kind of tinker around with it and try to get it set up and everything. So that's in the future, and we'll see how that goes, and for now we'll see if we can get this part machined up. Okay guys, we're back. I ran into a snag on the other setup I had. I didn't quite have enough travel for the Y here to machine this part the way I had it set up. So we're back on the fixture plate. This will give me an extended amount of travel. The way it's set up, I can travel almost, I can almost use my entire range of travel this way, and the other way some of my travel was being used up by my vise, so I would have had to have switched around my jaws so that I could push my part further back on my y-axis. So instead of changing the vise all around, I just decided to change the program around and change my setup so that I could set up on this fixture plate, and then I could just set my part down anywhere I wanted to and use my pins, my locator pins on my fixture plate to orient my part perpendicular to my axes. So anyway, it really does open up a lot of opportunities with this fixture plate, because you don't have to take your vise apart and come up with creative ways to get an extended amount of travel out of your setup. So this fixture plate has come in handy quite a few times, especially with this part like this one right here. The first time I machined it, it was extremely challenging, and this fixture plate really helped out a lot, made it possible to do that. So I'm really glad I made this fixture plate. So now we got it set up. I got it all probed in with the new setup. So we'll go ahead and try and see if we can get this part knocked out. Problems. What happened there, went in there and changed that program, and the optimal load setting on the adaptive for these slots was set too high. What I had to do was I just overrode the feed rate slow enough so that it would handle the optimal load. Now, if I had been using stepper motors, I don't think that would have ever been possible. I don't think they would have been able to keep up with the pressure that was being put on the tool. That's a good representation of how much power these servos have over stepper motors. With these servos, or any other kind of servo, you have so much more power to drive the tool. Now, whether your spindle can handle it or not, that's another problem. And you know you're in trouble, you can reduce the feed rate enough to handle the optimal load, therefore reducing the chip load. per tooth so that you can swing that tool through that path, that width of cut. That goes to show you right there how much more power the servos have over stepper motors in an actual situation. I don't know how I missed that. That was 150 thousandths step over in the adaptive, so that was way too much. I had intended on it being somewhere around 40 or 50 thousandths, but it ended up being 150 thousandths somehow. I don't know how it got there, but it got there, and we got through it. Overall, it's okay. It was mainly for roughing. So the trace that I ran around ended up cleaning it up, and there was just a little bit more material left on the trace due to the tool pressure that was applied during the adaptive. So I think the cleanup on the trace was supposed to be 5 thousandths, and it probably ended up more like 10 thousandths, or maybe a little better than 10 thousandths. So we made it through that part finally. It's been a challenge again. Even this part was a challenge to start with on the first time I machined it, so it has prevailed once again to be a challenge even the second time. So still learning these processes. So okay, next thing we're going to do, this is something I haven't done. I haven't ran my fly cutter in a sequence of processes, so now it's time to do that. We'll see how this goes, guys. I don't know. It's the first time I've ever done this, relying on my tool heights for this fly cutter. Well, that weren't too bad, I guess. That was the first time I ever ran the fly cutter in a series of tools, so came out pretty good. See how this chamfer works out. I'll get the tool changed out and we'll be right back. Okay guys, well I got one more setup for this thing. I got to flip it over and nail it back down to the fixture plate and face off the top surface up there for the gear drive case to mount to, so that everything is nice and machined surfaces going together, so everything is good and lined up. I'll probably do that off camera because it's just a simple 3-pass process, and you've just seen the facing of this bottom. It'll basically be the same thing, it'll just be on the opposite side just to clean up that surface. So that's going to finish up this part, and we'll move on to one of the other parts. I'm not sure. I'm going to have to kind of come up with a plan to alleviate a problem with some extruded tubing. The sides are just not straight enough on the inside to use, so I'm going to have to end up trying to come up with a different way to produce the case so that it's nice and square on the inside. Thumbs up if you like the video, subscribe if you like. Till next time, we'll see you later.